So let's analyze the twin paradox using a spacetime diagram. So recall that the situation is that Beowulf and Anastasia are together on Earth, and they're twins. They're both 25 years old. And Anna departs for Sirius, which is 8.6 light years away. So the departure will be event A, and that will occur at, we'll call time 0. And then 25 years later, Anastasia returns, and their reunion is event B. And so, as we discussed in the previous video, Beowulf is expecting that Anna will be younger than him when they rejoin, and Anna is expecting that Beowulf will be younger than her when they rejoin. So who is right, who is wrong? They clearly can't both be right at the same time. All right. So here's a space-time diagram, and Beowulf will be staying at the origin. And let's see here. So Anna is going to go out here, out to Sirius, and back like this. So very roughly, this might be Anastasia's world line. So travels at a significant fraction of the speed of light. Maybe, let's see, so this is, scale might be a little off. This is out to Sirius. That would be 8.6 years. These are years here. Okay, so at issue, right, is this proper time formula. So Beowulf here on Earth would measure a coordinate time for the event. So Beowulf's going to measure 25 years. The proper time for Anastasia, that's going to be delta tau, and that's going to be less because, well, tau is always less than t unless v is 0. And here v is going to be close to the speed of light. Just to put a few numbers on this, let's do a rough calculation for what delta tau would be. So Anna goes out to the star and back. So she travels 8.6 times 2. So that's 8.6 times 2. I really should need a calculator for that. 17.2 years. Let's do this here. So V is 17.2 years. That's the distance she travels. And she does that in 25 years. And I guess I'm going to put an approximate sign there because clearly her speed is changing. She accelerates, she slows down. So we're pretending that this is constant when it's not really, but this will give us a reasonable approximation. Let's see, 17.2 divided by 25, 0.69. So the average speed here is 0.69 times the speed of light. And let's plug that in here with a delta t of 25. So delta tau is going to be 1 minus 0.69 squared, square root times 25 years. All right, so 1 minus 0.69 squared equals square root times 25. I get about 18. So that means that when Anastasia returns to Earth, she's 18 plus 25, or 43, whereas Beowulf is 50. So about a 7-year difference. Okay, so that's how things look from Beowulf's point of view. And we got this number by using this formula. What about from Anastasia's point of view? So, so from Beowulf's point of view, Anastasia goes on a trip. From Anastasia's point of view, Beowulf goes on a trip. But here's the thing, and this is the resolution of the paradox. Anastasia is not in an inertial reference frame. She can't be. She's accelerating, and then she turns around. Her velocity is definitely not constant. An inertial reference frame is one in which velocity is constant. So that means that Anastasia is not measuring a coordinate time. She's not in an inertial reference frame. So that this formula does not apply to Anastasia. It only applies to Beowulf. So what that means is that it really will be the case that Anna is younger when they are reunited. Here's another way to think about this. So, principle of relativity says that the result of an experiment should be the same. The laws of physics are the same in all inertial reference frames. And so Beowulf definitely in an inertial reference frame. Anastasia goes out and comes back. You can think of this as we've conducted a physics experiment. We could also analyze the same experiment from Anastasia's reference frame where Beowulf goes and comes back. But again, the key issue here is that Anastasia is not in an inertial reference frame. So in other words, these reference frames aren't equivalent. So you could tell that that Anastasia could tell that she's not in an inertial reference frame because you can feel acceleration, right? If you're in a train that starts at rest, accelerates really quickly, slows down, turns around, and then decelerates when it hits Earth, you can feel that. Right? It's not an inertial reference frame, back to what we talked about in Unit 1. So when you're comparing inertial reference frames, there's sort of no way to tell who is really moving. Here, however, it's fairly easy to tell who is really moving because Anastasia is experiencing acceleration and deceleration. All right, so the last thing I want to point out is that strictly speaking, Beowulf's reference frame is not inertial either, because Beowulf is on the Earth, and the Earth is rotating on its axis, and is rotating around the Sun 25 times during here. But if we look at a really big scale, so a scale on which we could have the solar system here, and then all the way out here maybe would be Sirius, the star 8.6 light years away, the little bit of non-constant velocity that Beowulf has, because the Earth is rotating around the Sun, is very, very, very small compared to the non-constant velocity that Anastasia experiences. So to a very good approximation, Beowulf is indeed in an inertial reference frame, and thus is indeed measuring a coordinate time. So that is the resolution for the twin paradox. As I mentioned, this is a very, very famous, well-known example. There's lots written about it, lots of articles on the web. I think it has its own Wikipedia page. So if you want to dig deeper, there's lots of resources you can check out.